Welcome to video lecture on data structures. Myself, Dr. Shubha S., Assistant Professor, Department of Computer Science, Government First Grade College, Malleshwaram, Bangalore, would like to present this video lecture. In this video lecture, you learn about the technique of binary search, its algorithm, program, efficiency of binary search, advantages and disadvantages. Now let us learn about binary search technique. So in my previous video session, you have learned the drawback of linear search. So in a linear search, only after comparing all the n elements with the search element, we shall come to know that the element is not in the list. So this problem can be overcome when the elements are sorted and use the binary search technique. So binary search is considered as the most efficient method of searching a linear array without the use of the auxiliary indices. Now, the search element is compared with the middle element of the array. If they are same, the search ends successfully. Otherwise, the search should continue either to the left or to the right of the array in a similar manner. Now let us see the algorithm for binary search. So here, binary search is the name of the algorithm. A is the array with n elements and ELE is the search element. Low and high is the position of the first and the last element in the list, and mid identifies the position of the middle element. So step number 1, low is equal to 0. Step 2, high is equal to n minus 1. And step 3, while low is less than or equal to high, do mid is equal to low plus high divide by 2. If element is equal to a of mid, then return mid. Otherwise, if element is less than a of mid, then high is equal to mid minus 1, else low is equal to mid plus 1. And step number 4, exit. Now, let us see the program for binary search. So we have the variables here, n, which is used to read the number of elements in the list, and a is the array of the size 20, and ELE, it is the search element. I is used for looping purpose, and it will keep track of the count. And pause is initialized as -1. Low and high, they are used to identify the position of the first and the last element in the list. And mid identifies the position of the middle element in the list. So in the input statements, first we accept the size of the array. That is, we are going to accept the value of n and read the n numbers in the sorted order. So next we accept the ELE, that is the search element. And low and high, it is assigned with the value of 0 and -1. Now the logic of the binary search is, while low is less than or equal to high, we evaluate mid is equal to low plus high divide by 2. If element is equal to a of mid, then pause is equal to mid plus 1. Otherwise, if element is less than a of mid, then high is equal to mid minus 1, else low is equal to mid plus 1. So, and once when control comes out of the loop, we have the output statement. So if pause is equal to -1, print element not present or not found. Otherwise, we print the element found at position pause. So let us take an example here. We first ask for the user to enter the size of the array. So let us assume the user enters the number 5. Next, we request the user to enter 5 elements in sorted order. So we assume the user enters 12, 23, 34, 45, 67 in sorted order. So next we ask the user to enter the search element. So again we assume the user enters 67. Now the logic of the program is seen here. Low value is 0 and the high value is n minus 1, which means 5 minus 1, and which is equal to 4. So while 0 is less than or equal to 4, which means the true statement, the condition is true. So the control enters inside the while loop. Now inside the while loop, we calculate the mid value. So mid is calculated as low plus high divided by 2, which means 0 plus 4 divided by 2, which is 2. So mid value is 2. After that statement, we have a decision making statement, that is the if statement. So we check here if element is equal to A of mid, which means element is 67 and A of mid, that is A of 2. So A of 2 we have 34. So it is not true. Element which is 67, it is not equal to 34. So this statement is not true. So after that statement, we have again a decision statement. If element is less than A of mid, our element is 67, is it less than 34? It is again not true. So we come to the false block where low is changed to mid plus 1. That means previously low value was 0. Now it changes to mid plus 1. So mid value is 2. 2 plus 1 is 3. So low is 3 and high value is 4. So again the loop will continue. Is 3 less than or equal to 4? Again it is true. So mid value is again been evaluated here. Mid is equal to 3 plus 4 divided by 2. That means mid value is equal to 7 by 2, which is equal to 3, since we are doing integer division. So next we check if element is equal to A of mid, that is 67 and A of 3. So A of 3 is 45 here. So 67 and 45 is being compared. Now it turns to be false. So the control goes to the next statement, which is element less than A of mid. So here is 67 less than 45? Not true. So control goes to the false block. That means low value changes to mid plus 1. So that means 3 plus 1, which is equal to 4. Now again the while loop will continue. Now here low value is, that is mid plus 1, which was 3 plus 1. It has changed to 4. So is 4 less than or equal to 4? Yes, 4 is equal to 4. So it is true. Now the control enters inside the while loop. Now here again, the mid value is going to be evaluated. So mid is equal to low plus high divided by 2. That is 4 plus 4 divided by 2, which is equal to 4. So next is element equal to A of mid. Yes, element is 67 and A of mid. Mid is 4. So A of 4. A of 4 is 67. So 67 is equal to 67. It turns to be true. So inside the if statement, we have the true block, that is P pause is equal to mid plus 1. Pause, it was previously minus 1. Now that it changes to mid is 4, 4 plus 1, 5. So pause changes to 5. So now that the control comes out of the while loop and we have the output statement. And in the output statement, it is going to say that if pause is equal to minus 1, it would have print the element is not present. But since pause has changed to 5, we print the output statement as element 67 is found in position 5. Now let's see the efficiency of binary search. If the size of the list is n, then the maximum number of elements compared is approximately log n to base 2. And we can say that the efficiency of binary search is big O of log n. Advantages of binary search. So binary search is that the binary search is very efficient than the linear search algorithm because it takes less time to search a large list. But the drawback of the binary search is that the list should be a sorted list. And since it employs a recursive approach, it requires more stack space. Programming binary search algorithm is error prone and difficult. And lastly, it is practically useless in situations where there are many insertion and deletions. So now that we have come to the end of this video lecture, I hope you have understood the working technique of the binary search method. And in my next video, you will learn about multi-dimensional arrays. So thank you for watching.